Good day, students. Welcome to mathgodserve.com. In this clip, we're going to be going over the fundamental theorem of calculus, part 2. Before we get started, let's go ahead and take a look at the formula that can help us to apply the fundamental theorem of calculus, part 2. So FTC part 2. So if you're asked to find the derivative ddx of an integral expression, the integral from h of x to g of x of a function f of t dt, applying the formula for FTC part 2, this will simply be f of g of x times the derivative of g of x minus f of h of x times the derivative of x, h prime of x. And also, we can also extend this formula to a special case where one of the limits of integration is in fact a constant. So the derivative of the integral from some constant a to g of x with function f of t dt, the formula for FTC2 tells us that this is simply f of g of x times g prime of x. Okay? All right, so let's go ahead and try out some examples. So yes, the task is to find the derivative, find the derivative of the following using FTC 1 and 2. Okay, so we're going to use two methods to find the derivative of the following integral expressions. We're going to use the fundamental theorem of calculus part 1, and then we're going to use FTC2 as indicated in these formulas above. All right, so problem 1, what if we have y, the function y equals the integral from 3x to the natural logarithm of x of sine t dt. All right, so method 1, we're going to use FTC1. Okay, fundamental theorem of calculus 1. FTC1 is a little bit longer, but it really helps you to understand the process behind what's going on. FTC2 is very fast, but you might not really understand the mathematics that's behind the underlying process. Okay, all right, so let's take a look at FTC1. So we are to find the derivative of this function. So we have this expression right here. So the first thing you want to do is you're going to assign the integrand a function. Okay, so let's call the integrand sine t. Let's call it f of t. So let f of t integrand equals sine t. Okay, now we can now rewrite this function y equals the integral from 3x to ln x sine t dt as the integral from 3x to the natural logarithm of x of f of t dt. All right. Now, what we're going to do is we're going to find the antiderivative of f of t. Okay. So the integral of f of t is uppercase f of t evaluated from the lower limit 3x to the upper limit ln x. You might wonder, why did we make this substitution up here? You're going to see why we did that in a minute, okay? So we are calling f of t the antiderivative of f, which is the antiderivative of sine t. Notice we do not have to find the antiderivative of this function. We're just using a name, a functional name to represent the antiderivative, okay? So let's keep on going. This is still y. And then we're applying FTC1 right here, right? Because when you're looking for the definite integral, you're evaluating the antiderivative at the upper limit minus the antiderivative at the lower limit. So this is the antiderivative. What we're going to do, applying FTC1, we're going to evaluate the antiderivative at the upper limit of integration minus the antiderivative evaluated at the lower limit of integration. Okay? Remember, the task is to find the derivative. So let's go ahead and find the derivative. Okay, so dy dx. dy dx is going to be the derivative of this term minus the derivative of that term. Okay, so we're going to find f of ln x prime minus f of 3x prime. Now what you notice is that these two are composite functions, so we're going to have to apply the chain rule, all right? So what's the derivative of the uppercase of f? Remember, when you integrated or found the antiderivative of f, it became uppercase f, right? Now what happens when you take the derivative? You're going to end up with lowercase f, right? So you end up with f of what? F of ln x, using the chain rule, times ln x prime minus, in this case, the same story, f of 3x times 3x prime. Okay, so this is where you can see the reason why we made the substitution. When you're applying FTC1 and finding the derivative of integral expressions, you're going to be finding the antiderivative and then the derivative of the antiderivative. So instead of wasting time finding the antiderivative of a function, which you only find the derivative of later, you simply assign that function a variable, give it a name like f, and the antiderivative will just be the capitalization of that. And then when you take the derivative, you end up with the lower case. Okay, so that's why we made this substitution here, is to save us time. Okay, so let's go ahead and finish this off. Remember that f of t is sine t, right? So f of ln x, will simply plug in ln x into this function, evaluate f of t at ln x. Same story here. So dy dx is going to be sine of the natural logarithm of x times the derivative of ln x is 1 over x. Okay, minus f of x will be sine of 3x times the derivative of 3x, which is just 3. Okay, so let's go ahead and make our answer look a little bit pretty. dy dx is equal to sine of ln x over x minus 3 sine 3x. All right, so there goes your final answer. Now, let's go ahead and come up with the result using a different method, FTC part 2. Okay, so let's go ahead and do that. Before we start, let's go ahead and rewrite what the formula is for method 2. So method 2, we're going to use FTC2. Okay, so what is FTC2? Let's scroll up to see which of the variations we're going to be using. We're going to be using this formula right here, the first one. Okay, all right, so let's see. I'm going to rewrite the integral expression. So we have y equals the integral of 3x ln x sine t dt. Okay, so based on this formula up here, I need to know what g, h, and f of t are. Okay, so the upper limit of integration is our g of x, and this down here is our what? This is h of x, and then this function right here, one in blue, this is f of t. Okay, so the formula says that when we find the derivative, the y dx, let me write this in blue, the y dx is um, f of g of x times g prime of x minus f of h of x times h prime of x. So all we are simply going to do here is take the values of f, g, and h and plug it into this formula, and that'll be that. Okay, so let's go ahead and do it. So the idx is going to be f of g of x. So f of x is sine x. F of g of x is sine t evaluated at the upper limit. So that's going to be sine of ln x times the derivative of ln x, g of x prime, ln x prime. Okay? All right, that minus f of h of x, the function f evaluated at the lower limit of integration, sine 3x times the derivative of h times 3x prime. All right? And then our answer is going to be equal to sine ln x times the derivative of ln x, which is 1 over x, minus sine 3x times the derivative of 3x, which is 3. Okay, and then let's go ahead and make that look pretty. Partition our workspace here. So we're going to have, let's see, the y dx equals sine of the natural logarithm of x divided by x minus 3 sine of 3x. Okay? Now let's compare that to the answer we have here. That's exactly what we have. So we are confident that our answer is in fact correct. Okay? So there you have it. So thanks so much for taking the time to watch this presentation. We really appreciate it. If you have any questions or comments on this tutorial, feel free to include it in our comment section below. And also don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.